Okay, I've been getting some questions about how to alternate between combining the series rules and the parallel rules to solve a complex circuit like this. Let me walk through a solution, and you should pause the video at any point where you think you know what to do, solve it, and then check your answer. Okay, so filling in the values that are given, V total, R1, R2, R3. I've added a row to my table that doesn't exist in your handout. This is handy for keeping track of values that are intermediate values. I recognize that R2 and R3 are in parallel, so I've combined them using the parallel equation. 1 over R total equals 1 over, that thing. So I did the math on that ahead of time. That's 3.2 ohms. Again, this row doesn't exist on your paper. It's handy to slide it into the table. What I recognize here is R1 is in series with the subtotal R2 and 3. So I'm going to add 8 ohms and 3.2 ohms. R total is R1 plus R2, 3. 11.2 ohms. Okay. I look at the table and I ask myself now, what can I get next? It's always handy to go for the totals first. I see that I've got 2 of these. I can get the third. So V total equals I times R. That gets me a current of 0.71 amps. Now, where can I take this number next? The handy approach is to try to distribute this everywhere you can. The total current coming out of the battery is going to go through resistor 1. Therefore, I total equals I1 because series. So 0.71. Now, I know that I2 and I3 is also going to be 0.71 amps together, but I don't know how that breaks up here. So I'm going to just put this in as 0.71 amps on the subtotal line, I2 and 3. Now again, I'm going to look at what I've got. I've got an R and an I can get a V. .29, 2.3 volts. So again, V23 equals I times R. This is that subtotal line. Again, does not appear in your handout. Okay, let me look back at the picture and see if I can distribute either of these numbers anywhere. I know that I2 and I3 is going to add up to be this, but there's any number of possibilities that could add up to be 0.71. Not useful right now. What about the voltage? R2 and R3 are in parallel, and what I know about parallel resistors is they share the same voltage. They have 2.3 volts. V2 equals V3. Hope that shows up. Yeah, okay, good. So, look back at what I've got here. Hey, look, I've got R and V for both 2 and 3. I can get these two numbers now. Okay. The only number I haven't solved for here is this. So I know that V total is V1 plus the V2, 3. So this number plus this number has to equal this. And these are all of your answers for the solution for this problem.